Hello and welcome back. Today we're going to be looking at lesson 4.3. We're going to be looking at absolute value functions and actually the transformation of functions. Now this is going to be a really important topic. This will be a topic you're going to see throughout the year. This will be something that will be encountered with every single different type of equations we come to. Currently it is absolute value functions, but we'll tackle it again when we come to square root functions, when we come to quadratic functions, different power functions, logarithmic functions, sine functions, every single different types of functions we encounter, we're going to go through this idea of transforming, of the transformation of a parent function. So in our last video, we left off in what does the basic graph of an absolute value function look like? So it's important to know that our equation f of x equals that absolute value of x is what we're going to refer to as the parent function. And understanding its basic shape, it's going to sort of be that V-looking shape that goes to the origin and back up. That is sort of the parent function, or that base function that we're going to be referencing off of. I'll attempt to, throughout this video, every time we graph a parent function, I'll graph it in blue, and then we can see how the function manipulates with the different color red. So the parent function is that basic function of absolute value of x, and the goal today is to see, as we start changing the function, like we have in our first two examples here, how is that equation going to differ? So I'm going to start just by graphing the parent function in both of these problems. If I graph that parent function, parent function is going to be in blue for both of our graphs. So for both these graphs, we want to investigate what happens as we change our equation, as we put this addition to the equation. So our first equation, g of x, equals the absolute value of x plus 1. So what I'm going to do, what does that plus 1 do to the graph? Well, we could go to the table of values, and I would encourage you, if you wanted to go to the table of values and graph the original, graph the parent function, graph this equation, and see what happens. But one way to graph it is going to take that entire equation, and it's going to shift it up 1 point. It's going to shift it all up 1 point. So the new graph is going to be shifted up 1. Same deal over here, that minus 2 in the equation. What is that minus 2 going to do to our graph? Well, that minus 2 is going to shift everything down 2 points. So the graphs are now going to look like that. That number on the outside of the absolute value, so if we have this y equals the absolute value of x, I don't know, I'll use the letter d, a variable d. If you have something added or subtracted outside of our absolute value function, that value that's outside, added or subtracted, is going to be what we call a vertical transformation or a vertical shift. So D is, if I can spell the word, vertical shift. It moves the whole graph up or down, and it does exactly what it says. If D is positive, it goes up that many. If D is negative, it goes down. So just a quick example, if we said y equals the absolute value of x minus 7, what is the transformation on this graph? This graph, because of that minus 7, would shift down 7. If I had the equation y equals absolute value of x plus 3, what does that 3 do to my graph? Well, it's a positive 3, so it goes up 3. So if you consider the parent function of absolute value, if you ever, on the outside of the absolute value, and that's the important thing here, if the outside of the absolute value you add or subtract any value, that value will turn into the vertical shift of whatever it is. So that is the first of 3 transformations that we're going to look at today. And again, that vertical shift, as we move to other types of equations, is going to be the same. If it's on the outside, it is going to be that vertical shift. So what happens, though, if it's on the inside? Again, I'm going to graph my parent function in blue. So we have that base equation to sort of look at, so we understand what's going on here. what's going on here. Parent functions graph. So what happens now if we put that equation on the inside? Again, I would encourage you, for the first example, to pause the video, to go into your calculator, type that equation in, go to the table of values, and you can actually use those points on the table of values to graph it. Now, as a side note, as I'm bringing that up, talking about graphing it, do you know where to find absolute value in our calculator? So let's do this together. This equation, absolute value of x minus 4. So if I wanted to graph it, here, clear it out. The absolute value, to find absolute value, I'm going to click on the math button. I am going to arrow to the right once, under number, then option number 1 says ABS, absolute value. I'm going to hit enter. Now, depending which model of calculator you have, some of your calculators might have these vertical bars. Some of your calculators might have those vertical bars right there. Some of your calculators might just have ABS with parentheses. In either case, I can now type my equation, x minus 4. And if I were to graph it now, if I were to graph that equation, if we compare the parent function to what happened here, what happened to our graph? Well, this graph got shifted, it looks like it got shifted to the right. And that's exactly what happened. That's exactly what happened. If I were to graph this graph, let's use my other color, red, this graph here is getting shifted 4 units to the right. Now, if we repeat this process with the second equation, what's that 5 going to do? Well, if the minus 4 brought things to the right, the plus 5 is going to bring things to the left. So if we graph that equation, it's going to look something like that. So if we're adding or subtracting something to our equation that's inside the absolute values, that term turns into a horizontal shift. Let's go ahead and make that note here. If I went y equals the absolute value of x, either plus or minus c, let's use the variable c for us, this is what we're going to call a horizontal shift. It moves the graph left and right. But do note, as we do horizontal shifts, that shift is always going to be opposite to whatever the sign is. A minus 4 sends it to the right 4. A plus 5 sends it to the left 5. So the shift is always opposite whatever the sign is. And that's only true for the horizontal shifts. Maybe we should make a little note of that. Note. Shift C units in direction opposite of sign. Opposite of sign. So positive numbers go to the left, or negative numbers go to the right. So let's just try a few, make sure we have it. Y equals the absolute value of x minus 7. So that's going to be, because it's on the inside, it's going to be that horizontal shift, 7. So it's going to shift horizontally, 7 units. And because it's the negative, we're going to use the opposite sign. We're going to shift 7 to the right. It's opposite. If we had y equals the absolute value of x plus 2, again, this is going to be, it's on the inside. So this is going to be a horizontal shift. Because it's a 2, it's going to be 2 units. Plus 2 means 2 units to the left. We can shift it 2 units to the left. Oop, hitting the wrong buttons. Let's try that over there. Again, wrong button. Let's try it one more time. Now, what happens? Can we put these two parts together? Can we put the vertical and the horizontal together? What happens if we had an equation that was x minus 5 plus 4. We can put the horizontal and the vertical shifts together. So in this problem, what is the 5 going to do to our graph? What is that 4 going to do to the graph? Well, because that 4 is outside, the absolute values, that 4 is going to go, it's going to shift, it's a vertical shift. That 4 is a vertical shift 4 units up. And because that 5 is on the inside, we're going to have a horizontal shift 5 units, and horizontal shifts are the opposite sign, 5 units to the right. So we can put both those things together. Let's try one more like that. Let's say we had y equals the absolute value of x plus 3 minus 3. So again, we're looking at the two terms. That negative 3 is on the outside of our absolute value. Because it's on the outside of our absolute value, we're going to do a vertical shift, 3 units down. Because it's a negative 3, we go down. That positive 3 on this inside is a horizontal shift, 3 units. In the horizontal shift, we do the opposite. So plus 3 means we go to the left. So right now we're shifting our graphs up, down, left, and right. There's two more types of transformations that we're going to encounter. And these up, down, left, right, and our vertical stretch are going to be the transformations that we're going to see throughout the year. Again, let's start by having our parent function drawn. I'm going to draw it for both the equations real quick. And we're going to see what happens to the graph. Again, I'll go to the calculator. We'll try graphing it on the calculator, see how that looks. Then we'll put it on our graphs. So the first equation, we had the absolute value of x. The second equation, we had 3 times the absolute value of x. And when I graph them, first equation, absolute value of x. Second equation is 3 times the absolute value of x. We notice the line is steeper. It's kind of like a slope. That positive number, that value, changes the slope of our line. So now, our graph, instead of our parent function having a slope of 1, our graph now has a slope of 3. So if I go back to my problem, this 3 up here has changed my vertical stretch. It's changed the slope of my equation. So now it's going to look something like that. That number on the outside, that 3 on the outside, is what we call a vertical stretch. Vertical stretch, RTE. It has stretched the graph out. It has made it longer. It's changed the slope. So it's a vertical stretch of 3. Vertical stretch of 3. So if there's a number outside or in front of, the absolute value that's being multiplied, that's going to be our vertical stretch. So if we had y equals 5 absolute value of x, that's going to be a stretch of 5. Vertical stretch of 5. If you had, let's do just one more example of that. If I said y equals 1/2 times the absolute value of x, it's a vertical stretch of 1/2. It's going to make it a little bit shallower. But whatever that number in front is a vertical stretch. It changes the slope, essentially. What's the slope of the equation? Now, in that last example, what happens when we have that negative sign in front of it? Well, again, I'd encourage you to graph it on your calculator, but if you would do that, your graph helps if I can draw that line a little bit nicer. That graph would just flip over. It's what we call a vertical reflection. vertical reflection. It's flipped the graph over. Instead of the slope lines going up, they now go down. We flip it over. So if there's a negative sign, flip it over. Maybe you combine the two parts. Maybe you have an equation that is y equals -2 absolute value of x. Has a negative and that 2. This problem would be a vertical reflection or a flip. Some people call it a flip. A vertical reflection, and it is a vertical stretch of 2. It could have both those pieces together. The negative is the reflection, that 2 is the stretch. Now, we can put all of these parts, if we wanted to, we could put all of these parts together and have all these transformations in one equation. So let's take a look at that, and we'll call it there. -3 absolute value x plus 4 minus 7. So let's go through all those parts, see what happens, write some general rules for us, and then we'll call it a day. So what's happening? We'll go left to right. So that -3, what does the -3 do? Well, the negative in front, the negative is that vertical reflection. So we'll say it's flipped, or it's a vertical reflection. Reflection. That's that negative. That 3 is a stretch. We have a vertical stretch of 3. Going through, what does that 4, that +4, do to our graph? Because that +4 is on the inside, that's our horizontal movement, and we do what the opposite of the sign. It's a horizontal shift 4 units left. And finally, what does that 7 do? That -7 is a vertical shift. We're going 7 down. So we can put all these pieces together. Now, if you're looking for some general, like a general formula, general sort of rule of thumb, we can write this as something like this. A, absolute value x plus or minus c plus or minus d. That A, that number in front, is going to be is a vertical shift. Vertical stretch. That's that vertical stretch. Spell my words correctly, that'd be helpful. And is it flipped? It tells you direction of opening. Maybe that's a better way to phrase it. And it's the direction of opening. Positive numbers go up, negative numbers go down. Direction of opening. That C value in our equation tells us the horizontal movement, tells us the horizontal shift, and then that D value in our equation tells us the vertical shift. Vertical shift. Now, this vertical shift, horizontal shift, and vertical stretch are very important. We are going to, honest to goodness, you will see them in every single chapter from here to the rest of Algebra 2. You go on to pre-calculus or calculus, these rules of shifting will remain the same. Every chapter will have them. It does not matter the type of equation, does not matter the parent function that you're working with. We will have vertical shifts and horizontal shifts in all our equations. So, I encourage you, practice some problems, look at the notes, take your time, ask some questions. If you have any questions, let me know. Otherwise, be well, take care, and have a great day.